Have you ever questioned how or why fireworks produce such brilliant colors? The answer lies in one of chemistry's most fundamental concepts: electron energy levels. Inside every atom, electrons orbit the nucleus in a specific energy level. Usually, this energy level is the ground state energy level, which is the lowest energy level that an electron can occupy. But an electron can also absorb energy, allowing it to jump from the lowest energy level to a higher energy level, which is what we would call an excited state. The issue is that excited electrons are inherently unstable. They want to drop back down to their ground state, but in order to do so, they must release the energy that they gained. When they release this energy, it is released as a photon of light, and the color of this photon is dependent on the energy gap between the different levels that it jumped between. So let's connect this back to fireworks. When you light a firework, you're initiating a high-temperature chemical reaction. This heat provides the energy needed to excite electrons in metal atoms within the fireworks composition. Different metals have different arrangements of electron energy levels, which means they release different colors of light. So why is a photon's color fixated by its energy levels? We can think of it like a ladder, where each rung is a whole number and you can't stand in between the rungs. Atomic energy levels work the same way. There is no freedom to choose in between values, so when an electron jumps from one energy level to another, the energy change is perfectly fixed. There is only one possible energy difference, so the photon produced must carry exactly that amount of energy. Higher energy corresponds with a higher frequency, which corresponds with bluer or violet light, and lower energy corresponds with lower frequency, which corresponds with redder light. And these colors are fixed because the level spacings are fixed. Strontium, for example, produces red light because the energy gap between electron levels in strontium atoms corresponds to red wavelengths. Copper compounds create blue light, and barium compounds produce green for the same reasons. This process happens remarkably fast. An electron absorbs energy from the explosion, jumps to a higher energy level, and then almost immediately falls back down. When it falls, it releases a photon of light. This happens billions upon billions of times in a single firework explosion, creating the colors that we see in the night sky. So the next time you watch fireworks, remember that you're watching chemistry in action. Every burst of color is the result of electrons jumping between energy levels and falling back to their ground state. It's a perfect example of how understanding basic scientific principles can allow us to appreciate the beauty of the world around us and the shows it allows us to create.